Hello and welcome. My name is Brian Chu. I'm a Microsoft technical trainer. I'm here to walk you through the AZ-800 Administering Windows Server Hybrid Core Infrastructure course. Let's get started. In this session, we'll focus on managing virtualization and containers in a hybrid environment, with a special emphasis on Hyper-V in Windows Server. We'll cover both on-prem and hybrid scenarios, so you'll be ready for real-world environments where workloads can run anywhere. Let's start with the basics. What is Hyper-V? Hyper-V is Microsoft's native hypervisor built into Windows Server that allows you to create and run multiple virtual machines on a single physical server. This means you can consolidate workloads, save on hardware costs, and increase flexibility in your IT environment. Think about your current environment. How could running multiple VMs on a single server help you consolidate workloads or test new applications safely? Hyper-V supports a wide range of guest operating systems, including Linux distributions, multiple versions of Windows Server and Windows Client OSs, and free BSD. To ensure compatibility, you will need a 64-bit processor that supports second-level address translation and VM monitor mode extension. It's important to allocate enough memory to handle anticipated workloads, and the virtualization technology must be enabled in your BIOS, either Intel VT or AMD V. Additionally, make sure that hardware-enforced data execution prevention (DEP) is active. There are two primary ways to install the system. You can use Server Manager for graphical interface-based installation, or you can automate the setup process by employing the Install Windows feature PowerShell commandlet. Always check compatibility and requirements before enabling Hyper-V on your hardware. Hyper-V Manager serves as the primary graphical interface for managing Hyper-V infrastructure. Through Hyper-V Manager, administrators can create, configure, and oversee virtual machines and virtual switches, access VM consoles, and administer multiple hosts from a unified interface. In addition to Hyper-V Manager, there are several other management tools available. Windows PowerShell enables automation and scripting capabilities, while PowerShell Direct allows direct management of VMs from the host, even when the network connectivity is unavailable. Windows Admin Center provides a web-based platform for server and cluster management, and SSH Direct makes it possible to establish secure connections to Linux virtual machines. For large-scale deployments, it is advisable to utilize Virtual Machine Manager for cluster management, or implement Windows failover cluster solutions to ensure high availability. To achieve optimal performance and security when using Hyper-V, it is essential to follow several best practices. Start by ensuring that your hardware is sufficiently powerful to accommodate all the virtual machines you plan to run. To enhance both performance and reliability, consider deploying your virtual machines on separate disks. or use clustered shared volumes. It is best to dedicate your Hyper-V host solely to virtualization and avoid installing any other server roles on it. Utilizing server core installation is recommended, as this approach reduces the attack surface and minimizes resource consumption. Make it a routine to run the best practice analyzer and enable resource metering to monitor and maintain system efficiency. For streamlined administration, manage Hyper-V remotely using remote server administration tools. Additionally, enabling enhanced session mode can offer better interaction with your virtual machines, though this step is optional. Hyper-V provides flexible networking options for your VMs. Choose the right adapter and switch type based on your VM's needs. External for internet access, internal for isolated lab environments, and private for secure VM-to-VM communication. Hyper-V networking offers a range of advanced features designed to improve both performance and security. Bandwidth management enables you to specify minimum and maximum bandwidth settings for each virtual machine's network adapter, ensuring efficient network resource allocation. Security features such as DHCP guard and router guard help prevent rogue DHCP servers and unauthorized routers from causing network disruptions. Port mirroring makes it possible to monitor network traffic for troubleshooting or security analysis. With NIC teaming, you can combine multiple network adapters to provide load balancing and failover capabilities. Other high-performance networking options such as VMQ, IPsec offloading, SRIOV are geared toward scalable and efficient network operations. Additionally, Network Address Translation (NAT) allows your virtual machines to access the internet securely without being directly exposed. Nest virtualization allows you to run Hyper-V inside a VM. This means a guest VM can act as a Hyper-V host and run its own VMs. Why is this useful? It is perfect for test and development labs. It enables you to simulate complex environments without extra hardware. To enable nested virtualization, both the Hyper-V host and the guest VM must be Windows Server 2016 or later. The VM must have enough memory and a compatible processor. The VM configuration version must be 8 or higher. While the VM is off, run PowerShell on the host to enable this feature. Enhanced session mode improves your experience when connected to VMs. You can copy and paste files test between the host and VM. Share devices like microphones and USB drives. Change VM display resolution on the fly. This feature is only available for Windows VMs. GPU partitioning lets you share a single GPU among multiple virtual machines. Each VM gets a predictable share of GPU resources. This reduces infrastructure costs and increases scalability. Integration services are components that allow VMs to communicate with the Hyper-V host. Some services are essential for monitoring and backup, while others add convenience. Now, let's dive into managing Hyper-V virtual machines themselves. We'll cover VM settings, storage, states, checkpoints, and more. Each VM has a configuration version that determines compatibility with the Hyper-V host. For example, Windows Server 2025 supports version 8 through 12. For VM generations, Generation 1 supports legacy BIOS, while Generation 2 is a 64-bit only, supports Secure Boot, UEFI, Shield VMs. Generation 2 VMs use fewer resources and are more secure. When creating a new VM, consider which generation and settings best fit your workload's requirements. Remember, Generation 1 VMs are for legacy BIOS setups, while Generation 2 VMs are for modern, secure environments. Let's talk about dynamic memory in Hyper-V. Dynamic memory allows a virtual machine to use only as much RAM as it needs at any given time, rather than reserving a fixed amount. This means you can run more VMs on the host, making better use of your hardware. Some older applications may not support dynamic memory and require a fixed amount. Always monitor your VMs and adjust the settings based on real usage. When planning storage for your virtual machines, consider performance, redundancy, and growth. Think about where you'll store your VM files, local disks, SAN, or network shares, and choose the best option for your environment. Hyper-V supports two main virtual hard disk formats, VHD and VHDS. When creating new virtual machines, use VHDS, unless you need compatibility with older systems. There are several types of virtual hard disks. Fixed allocates all disk space immediately, best for performance and predictability. Dynamic grows as needed, saving space, but with a slight performance cost. Differencing tracks changes from a parent disk, useful for testing or templating. And last, pass-through connects directly to a physical disk or iSCSI. For clustered environments, such as failover clustering, where multiple VMs need access to the same disk for high availability, you may need to share a virtual disk between multiple VMs. You can use shared VHDX or VHD set. It is recommended for new deployments, especially with Windows Server 2016 or later. A VM can be in several states, and checkpoints let you capture the state of a VM at a specific point in time. But please note, checkpoints are not a replacement for backups. Use them for short-term rollback, not long-term protection. You can move VMs between hosts using import and export. For example, you can export a VM from a test environment and then import it into production or another lab. Discrete Device Assignment, DDA, lets you assign a physical PCIe device, like a GPU or storage controller, directly to a VM. A typical use case is a VM needs exclusive access to a specific graphics card for high-performance workloads. Deploying discrete device assignment requires careful planning. First, make sure you are using supported virtual machines, either Generation 1 or 2. Second, running Windows 10, Windows 11, Windows Server 2016 or later. Your system must have server-class hardware with the PCIe control capabilities. When selecting devices, always check compatibility. It is essential to install the appropriate device driver within the virtual machine. Beware of DDA's limitations. Additionally, you must ensure there is enough memory-mapped I/O space allocated for the device. To assist with planning, take advantage of the provided PowerShell script to access your hardware and plan your MMIO allocation effectively. Now, let's focus on securing your virtualization environment. We'll cover features like guarded fabric, attestation, host guarding service, and shield VM to protect against inspection, theft, and tampering. A guarded fabric is a security solution that protects VMs from inspecting, theft, and tampering, even from administrators or malware on the host. This feature is very useful if you need to ensure that sensitive VMs can only run on trusted, healthy hosts. This slide demonstrates the components of a guarded fabric. First, guarded Hyper-V hosts. Only these can run shield VMs. Host guarding service provides attestation and key protection. Shield or encryption-supported VMs. VMs protected by BitLocker and other security features. System Center Virtual Machine Manager and PowerShell can automate and manage guarded fabrics. Attestation is how the system verifies that a Hyper-V host is trustworthy. There are two modes: TPM Trusted Attestation and Host Key Attestation. Choose TPM Trusted Attestation whenever possible for maximum security. The Host Guardian Service, HGS, has two main roles: attestation service and key protection service. HGS ensures Secrets are protected during VM creation. Only authorized hosts can start shield VMs. There are two main types of protected VMs: encryption-supported VMs and shield VMs. Both support secure boot, virtual TPM, and encrypted state life migration. Shield VMs block certain integration components for extra security. Use shield VMs for highly sensitive workloads. If you need to debug or use serial ports, choose encryption-supported VMs. For maximum isolation, use shield VMs. To create a shield VM, first step is to create a shield VM template disk. Then, create a shield data file with the shielding data file wizard. Next, deploy the shield VM with the System Center Virtual Machine Manager or PowerShell. Following Microsoft Docs for detailed step-by-step instructions. This diagram demonstrates what happens when you start a shield VM. As we can see, only healthy, trusted hosts can start shield VMs, ensuring your sensitive workloads are always protected. Containers are a lightweight way to package applications and their dependencies so they can run anywhere, on your workstation, on servers, or in the cloud. A container is a package that includes an application and all its dependencies. Think of a container like a lunchbox. It keeps everything your app needs together, so you can take it anywhere and it works the same way. Containers and virtual machines both provide isolation, but in different ways. Containers share the host's operating system kernel, making them lightweight and fast to start. For virtual machines, each VM runs its own OS, providing stronger isolation but using more resources. Use containers for lightweight, scalable apps. Use VMs for workloads needing full OS isolation. There are two main isolation modes for containers. Process isolations. Containers share the host kernel, but have separate user spaces. It is fast and efficient, but less secure. Hyper-V isolation. Each container runs inside a lightweight VM with its own kernel, provides stronger security and stability. For most workloads, process isolation is fine. For sensitive or multi-tenant environments, use Hyper-V isolation. Docker is the most popular platform for managing containers. Docker Engine runs containers on Linux, macOS, or Windows. And the Docker client is a command line tool to build and manage containers. Docker uses open standards, so your containers can run anywhere. To run containers on Windows Server, install a supported container runtime. you can choose Docker CE, Moby, Kubernetes Container Runtime, Containerd. Docker Hub is a web-based registry for storing and sharing container images. Access thousands of ready-to-use images for your projects. Always use the latest supported runtime for security and compatibility. A container-based image provides the foundational OS layer for your container. Use Docker pull to download images from Microsoft Container Registry. Nano Server is for .NET Core apps, ultralight. Windows Server Core is for traditional .NET applications, minimum size. Windows Server, full Windows API support, slightly smaller than Windows image. And finally, Windows, largest image, full API set. You can create and manage containers using Docker commands in this slide. Automate your builds with Docker files for consistency and repeatability. Docker networking works with Hyper-V switches and a Windows firewall to create secure, flexible networks for your containers. Windows supports 5 networking drivers for containers. Choose the network driver that fits your infrastructure and the security needs. Windows Admin Center is a browser-based graphic user interface for managing Windows servers, clusters, and hyper-converged infrastructure. To manage containers, first, install the containers extension. Then use tabs for summary, containers, images, networks, and volumes. To install Docker on Windows Server, first, install the Docker Microsoft Package Management Provider. Then, install Docker. You may need to restart the server if containers feature is also installed. Now, let's look at container orchestration, automating and managing large numbers of containers using tools like Kubernetes. Container orchestration automates deployment, scaling, and management of containers. If you just have a few containers, manual management is fine, right? But with hundreds or thousands, you need automation. Think of orchestration like conductor leading an orchestra, making sure every instrument/containers plays at the right time. Orchestration involves scheduling containers, managing affinity and anti-affinity, which containers run together or apart, health monitoring and failover, scaling up or down, networking and service discovery, coordinated upgrades. Popular tools include Kubernetes, Docker Swarm, Apache Mesos. Kubernetes is the leading container orchestration platform. It uses a cluster mode, master or control plane schedules, and manage workloads. And worker nodes run containers. They can be Windows or Linux. Kubernetes automates deployment, scaling, and management, making it ideal for large, complex environments. Kubernetes pods. A pod is a group of one or more containers that share storage, network, and specifications for running. Pods are distributed across worker nodes in a cluster. Think of a pod as a carpool, multiple containers traveling together, sharing resources. Let's walk through the high-level process of deploying Kubernetes resources. First, create a Kubernetes master. Second, configure a network solution. The third step is to join worker nodes. A worker node run the actual application workloads in the pods. And the final step is to manage Kubernetes resources. Use kubectl to deploy and manage pods and other resources. Azure Arc is Microsoft's solution for managing complex distributed environments. It extends Azure management to on-prem infrastructure, multiple clouds, including third-party clouds, and edge environments. With Azure Arc, you can manage and configure Windows servers, Linux servers, VMware vCenter servers, and Kubernetes clusters, even if they are not running in Azure. Use familiar Azure tools like Azure Resource Manager, Cloud Shell, the Azure Portal, and Azure Policy to manage all your IT resources. Azure Arc also extends DevOps practices, security policies, and data services to all your environments. Azure Arc acts like a bridge, connecting your on-prem, multi-cloud, and edge resources to Azure. This unified approach lets you apply Azure management, security, and governance everywhere, not just in the cloud. Think about your current environment. How could centralized management and policy enforcement help you simplify operations and improve security? With Azure Arc-enabled Kubernetes, you can manage Kubernetes clusters running on-prem, in other clouds, or at the edge, all from Azure. You can also bring Azure features like the Azure Portal, Resource Graph, Policy, and Monitor to your Kubernetes clusters. Azure Arc-enabled Kubernetes uses several agents to manage and monitor clusters. These agents work together to ensure your clusters are always in sync with your desired state and Azure policies. Here's a high-level overview of connecting a Kubernetes cluster to Azure Arc. Please follow the official Microsoft Learn documentation for a step-by-step instructions and troubleshooting. Now, it's time for us to get practical experience in Lab 5. In this lab, you'll perform a proof of concept to validate using Hyper-V to manage Contoso's virtual machines environment. You'll also work with the DevOps team to evaluate using Windows Server containers and manage them in Windows Admin Center. In this lab, we will implement and configure virtualization in Windows Server. We will first launch Server Manager. And let's take a look at Hyper-V setting. As you can see, SEA SVR1 has already installed Hyper-V feature. So let's choose Hyper-V Manager. So as you can see, there are no virtual machines currently running on this Hyper-V server. What we will do first is we will first create virtual switch. So let's select Virtual Switch Manager. And for the very first one, we will choose Private Switch. And let's click Create Virtual Switch. And we will change the default name to Contoso Private Switch. And we click Apply. The next step for us is to create a virtual hard disk. So let's select hard disk. And then next. So we will use the VHD format for this hard disk. And we will choose differencing. And click Next. So here we will set up a base image VHD. We will provide the name of the VHD and its location. All right, and we configure the parent virtual disk. Let's click Finish. So this will create a new virtual disk for us. Next up, let's create a virtual machine. So we choose Virtual Machine. Let's name this virtual machine as SEA VM1. And let's select Store the virtual machine in a different location, because we have already created the virtual disk for this virtual machine. So we will use CM base for the location. And let's click Next. For the generation, we will choose generation 1 here. And for the startup memory, we will change it to 4 gigabytes. And then we will select the private switch we created earlier. All right, and we will use an existing virtual hard disk. And we will select the virtual disk previously created. And that's it. So we created the virtual machine. Next up, we will manage the virtual machine with Windows Admin Center. So we will switch gear to Windows PowerShell. And then we will install Windows Admin Center in the local server. So let's first download the installation package. And after that, we will use the silent mode to install the Windows Admin Center. So this lab demonstrates that we can use different tools to do the Hyper-V management. So after the Windows Admin Center is installed, we first add the connection to the SCA-SVR1 Hyper-V host. We click the Add button, and we copy and paste the FQDN of the Hyper-V server. So the Hyper-V server is installed on SCA-SVR1. Since that remote server is a server core installation, so we can take advantage of Windows Admin Center for easy management. All right, and then let's do the management right from Windows Admin Center for this server. So first, let's take a look at the settings of the remote Hyper-V server. And as you can see here, the virtual machine we previously created is listed here. It is in a stopped status. So we can continue the management work right from Windows Admin Center. Let's click Settings. And here we can create a new virtual disk from Windows Admin Center for the SCA VM1 virtual machine. So we click Add Disk. And for the new virtual hard disk, we will just create a size of 5 GB as a demonstration. Let's save disk settings. Cool. All right. You can manage the virtual machine right from Windows Admin Center. Right? You can start the virtual machine from Windows Admin Center without heading back to Hyper-V server management tools. All right. Next, we will use the built-in remote PowerShell feature in Windows Admin Center to install and configure containers on the Hyper-V server. You can also do that locally on the SCA Admin1 server if you choose to. So to do the PowerShell remote session, you need to first create the session. And after that, we will install Docker on the remote Hyper-V server. So the very first one is to get the installation PowerShell. And then we can start the Docker Community Edition installation on the remote server. Remember, if this is the very first time you install the containers feature on a Windows server, you may need to reboot the server. After the containers feature is installed and the remote server is rebooted, we can continue with our setup. So let's first take a look at some of the well-known Docker commands. We will use Docker images to list the existing Docker images on the remote server. As we can see, there are currently no Docker images existing on the remote server. So we will use a Docker pull command to download a Windows Nano server to the remote Hyper-V server. So it will kickstart the downloading process. This time, if we rerun the Docker images command, we will see the image is available on the remote server. We can also use Windows Admin Center to verify our setup. And let's click the settings. So first we need to make sure that the extension is installed. So we will choose containers and we will get this extension installed. Let's verify that the extension is successfully installed. Cool. Then we can go to Server Manager and choose the remote Hyper-V server. Since the containers extension is already installed, we can take advantage of the extension to do the remote management. So we click the Containers tab. And if we click Images, you will see that this one is the image that we just downloaded to the remote server. You can also get an overview of the current status for the Docker images and containers right from Windows Admin Center. This concludes our session. You've completed this session on administering Windows Server hybrid core infrastructure with a focus on virtualization, containers, Kubernetes, and Azure Arc. There are many ways to continue your learning journey. We encourage you to watch other videos in this course, or search out your next favorite topic on Microsoft Learn at aka.ms/learn.